Many people often ask this question. If the sun exists in space, people who ask this usually think space only contains our sun, which emits light, and beyond that, there's nothing else. But, did you know, our sun is actually considered a small star, and expecting night to shine like broad daylight, like the light we get from the sun, even with trillions of stars. Remember, the distance between them, and the objects in space, is immense. We're talking millions, sometimes billions, of light. It's about 4.2 light-years away from Earth. That might not sound too bad, but 4.2 light-years is a mind-blowingly huge distance. Just imagine that to 63 centuries. To put it in perspective, if you boarded a spacecraft today, and even at that speed, interstellar travel is impossible. For now, in ancient times, people believed that the speed of light was infinite, that it traveled instantly. They thought light from stars reached us directly and immediately. When you press the button now, the bulb could take 5 to 20 minutes to light up, depending on Mars' position. That is how long the signal would take to get there, traveling at the speed of light. Now, if you placed that bulb in the Andromeda galaxy, the closest large galaxy to our own, and pressed the button from Earth, in space, it's painfully slow. Because space is unfathomably vast, and light, while fast, still has a limit. The bulb wouldn't light up after a few hours. If light is that slow, how do we communicate with the rovers on Mars? Great question. Whenever we send a signal to Mars or receive one, it takes anywhere from 5 to 20 minutes to arrive. Changing the state of the Earth particle instantly affects the other. Without any delay, they remain linked, no matter how far apart they are. Almost as if the universe is one giant, interconnected web. Even if they're billions of light-years apart, the change happens instantly. Research into quantum entanglement is ongoing, but one thing is becoming clear. Our universe, with all its galaxies, stars, and solar systems, may be deeply and mysteriously linked in ways we're just beginning to discover. Even though the signal travels at light speed, the distance causes that noticeable lag. Take care, and I'll see you in the next video. Not after 100 years, not even after 1,000 years. It would light up after about 2.5 million years. Now, let's really stretch things. Imagine putting that bulb in the Alpha Centauri star system. Press the button on Earth, In this phenomenon, two particles become entangled, deeply connected, no matter how far apart they are. And ironically, it's still the closest galaxy to us. Scientists even estimate that in a few billion years, Andromeda and our Milky Way will collide and form a single, massive galaxy. And the bulb wouldn't light up in minutes or hours. It would take more than 4 years to turn on. It doesn't mean it just exploded. It could have exploded millions of years ago. We're only seeing it now, because the light has just reached Earth. In reality, you're looking at old light. That star may not even exist anymore. Not only would your entire lifetime pass before getting even close, but dozens of your future generations would be born and die. But today, we understand, that's not how it works. If a star somewhere in space were to explode, we wouldn't see it immediately. Even if our own sun exploded, we wouldn't know for a full 8 minutes, because that's how long sunlight takes to reach Earth. Before anyone ever arrived, even if humans lived 1,000 years, it still wouldn't be enough. And stars like our sun, yes, this exact type number more than 100 billion, in just our Milky Way galaxy alone. Now here's something even more astonishing. There are stars so massive in this galaxy that billions of suns like ours could easily fit inside them. And yet, despite these enormous stars, we still observe darkness in space. And these stars, they're not exclusive to the Milky Way. Let's imagine this. You have a remote-controlled bulb. You press the button, and the bulb turns on instantly. It seems immediate, right? Now, let's take that same bulb to the moon. Assume the remote signals are strong enough to reach it. This time, when you press the button, the bulb turns on to 2.5 seconds later. That delay, that's proof light and electromagnetic signals travel at a finite speed. There are billions upon billions of other galaxies out there, and in every one of them, there are trillions of stars. Still, space remains dark. So what's the reason behind this darkness? And reaches our eyes. If there's nothing in its path, we simply see darkness. Since most of space is empty, and celestial objects are so far apart, most of the light travels through empty voids. So despite all the light stars emit, we still see blackness. because there's nothing for that light to bounce off. That's why space appears dark. Well, the first major reason is space is vast. Incredibly vast. And even with all those stars, they're still sparsely scattered in that endless expanse. In fact, when we compare stars to the size of the universe, it's like placing billions of light bulbs across the Earth. And here is a crucial point. Light is only visible to us when it hits an object, reflects off of it. Now that explains the darkness in space, but here's another popular question. Can we travel to another star? Can we, in today's age, reach another solar system or its planet? The answer is no. Not yet. Let's say we want to go to the nearest star beyond our sun, Proxima Centauri. Even using the fastest spacecraft ever built, it would take us about 6,300 years to get there. Right now, the fastest spacecraft we've ever made travels at around 163 kilometers per second. So, if a star exploded millions of light years away, they assumed we'd know right away. So, how do we know light has a limited speed? Now imagine taking that bulb to Mars. The distance from Earth is much greater. Why? Because Alpha Centauri is over 4 light years away. Yes, 2.5 million years just for the signal to reach Andromeda. That's because Andromeda is around 2.57 million light years away. So what does all this tell us? It tells us that even though light feels blazingly fast on Earth... Now, you might be wondering, so if you ever see a star in the night sky suddenly disappear. Now, let's explore something even more fascinating. Quantum physics introduces a concept called quantum entanglement. So, if one particle is on Earth, and its entangled partner is in another galaxy, this was so mind-boggling. Even Einstein called it spooky action at a distance. It seems, for entangled particles, distance doesn't matter. So, even though stars and galaxies appear far apart, at a quantum level, they might be more connected than we can possibly comprehend. I hope this video sparked your curiosity. If you enjoyed it, give it a like. And don't forget to subscribe for more amazing insights into science and space.